So in this video, we'll be talking about routing protocols. So why is routing protocols important? It's because of these 4 reasons. Number 1, it learns routing information on IP subnets from its neighboring routers. Number 2, it advertises routing information on IP subnets to the neighboring routers. So it learns from them and it advertises to them about IP subnets. And number 3, if there's more than one route exists to the same subnet, then the routing protocols needs to decide which one is the best route. And they usually use this thing called metrics to measure it. And number 4, routing protocols helps routers to react to changes, like how fast, say like if there's a change in the topology, like a route becomes unavailable, how fast can the routers learn about this unavailable route? So it's called convergence. Now, routing protocols, there are 2 types of it. The first one is interior gateway protocol. The second one is exterior gateway protocol. For exterior, it's pretty simple. It's usually just BGP. But for interior, there are 2 major types. The first type is distance vector. A really good routing protocol to represent this distance vector is RIP. And as well as there's also a link state, and a really good example would be OSPF. So the difference between the 2 is that with distance vector, the router sends out full routing table periodically to let its neighboring routers know this is what I have, even if there's no change in the topology. So it takes up a lot of bandwidth and resources. And also, distance vector uses hop counts as metrics. So each router is a hop. We'll talk about that over here. So for link state sends link state partial update when there's a change in the topology. So it doesn't send out the full routing table periodically for no reason. And for link state, it also has a better picture of the whole topology. And there's one more thing I didn't put it here. Typically, link state interior gateway protocols, they have 3 tables, which are neighboring table, topology table, and routing tables. We'll get into that. So over here, I want to talk about the difference between RIP, routing protocol, and EIGRP. So we have 2 topologies that are exactly the same thing. So right here, that's router A, B, C, A, B, C. And the bandwidth from A to B is 100 megabytes per second. So same as here. And B to C is 1 gigabyte per second. And then C to A is 1 gigabyte. Now, let's say we are going from router A to router B. Okay? From router A to router B. Obviously, there's 2 routes here from router A's point of view, right? Router A can go this way and then up, or router A can just go this way. Now, when you use RIP uses hop count as metrics, meaning that each router is a count. So from A to B, well, there's no router in between, right? So the matrix will be 0. But if they take this route right here, the matrix is 1 because there is a router C in the middle. So going this way, 0. Going this way, that's 1. So RIP is going to choose this route right here. Now, do you see the problem? It's pretty obvious. The problem is that link speed is slow compared to the 1 gigabyte. Hence, EIGRP is smarter. EIGRP metrics uses bandwidth and link delay. And it forms a calculation and tells you the number. So EIGRP knows that this route compared to this route is way slower because of the bandwidth. So EIGRP is going to pick this route, which is the correct answer. Next. So in this diagram, I want to talk about how to read an entry from the routing table for a route. for a subnet that's learned through EIGRP. So right here we have 3 routers. Each one has connected to a subnet. And then between there's a serial line with their own subnets. So now let's look at it from R3's point of view. So from router 3's point of view, it has learned 192.168.10.64. So this router right here has learned about this route through EIGRP. Now this number is the administrative distance. I'll go into it in a little bit. And that's the metrics number via 192.168.10.10. And that's this number right here. That's the next hop IP address. Usually there's a time, but I abbreviated out of serial port 00. So serial port 00. So R3 learned about this subnet using EIGRP and via next hop IP address out of this serial port. Now, why is administrative distance number important? It's because a router can have different routing protocols configured on it. So different routing protocols have different ways of calculating its metrics. So you can't really compare the metrics between 2 different routing protocols. For example, RIP. Usually the number is 0, 1, 2, 3, 4, 5, 6, 7, depending on how many routers are in between, from the starting point to the end point. Now, with EIGRP, as you can see, the metrics is based on bandwidth and link delay, and the calculation come up with large numbers. So you can't really take this number and compare with RIP's metric number. So the solution is, let's look at administrative distance. So AD, you can think of it as like a trustworthiness. So if it's direct connected route, the number is 0, so it's most trustworthy. If it's static 1, EIGRP 90, OSPF 110, and RIP 120.